All right, in today's lab, we are in lab 11 on electrochemistry. We're setting up an electroremediation cell, similar to what's in figure 11.3 in your book, page 5. And we will be plating the copper out on that spoon, but keep in mind that's just to make it obvious what the target is. So for the first thing we have to do is we've dried this spoon. We have to take the mass, and the original mass is 39.4076 grams. So make sure you record that data. So again, we're setting up a remediation cell, so we're not plating, we're not putting copper on the backside. We actually have an inactive black carbon electrode on the backside. So pay attention what leads go to where. So the carbon is already hooked up to red, which means it's positive, which means it's going to pull electrons off. That's where oxidation is going to take place. We're forcing oxidation to take place. We're going to check the temperature of the fluid at the start. We're going to check the pH at the start. So we're getting all set. Let's check the temperature. It's a little hard to see, so that it came out at 20 degrees. And it's hard to see, but it's right on the line there at 20. So now it's time to check the pH. So we have a universal paper. Kind of has, it's a little older, but you know, you have 1, 3, 5, 7, 9, and 11 pH. So somewhere around that brownish to green would be a neutral pH or slightly acidic. So we're putting that in the solution. Checking the color. And yeah, the color is a little lower than the neutral, but it's pH 6. Copper. So notice that we set up the red wire over to the inactive carbon electrode. That is where oxidation is taking place. So it's stripping electrons off. Now we're going to put the black electrode, which is negative. It's going to force electrons onto things. So that's reduction. That's getting set on the copper spoon. So now the first time that we registered voltage was 1.60 volts. And then that's an important mark because that shows the overpotential. And then we start running the experiment at 2.8 volts, 2 amps for 10 minutes. So 2.8 volts, 2 amps for 10 minutes. So now, sometime later, we're going to go back. I just want to show you while this is occurring. You might notice the voltage has dropped just a little bit. But while this is occurring, we're going to actually go down and look at the carbon electrode and see what's going on. We're going to just zoom in because this is a real important observation. It's going to help you understand a lot about this experiment. So looking at the oxidation, right? The anode, the inactive carbon. Oh. What is going on?
Make me happy. Make me feel fine. Tiny bubbles.
All right, so we now know that oxygen is being released at the anode. We've ran it 10 minutes. We're going to end at 2.7 volts and 2.10 amps. Make sure you make a note of that because obviously the voltage is dropped while the current has increased. That says something about conductivity. So you don't want to miss that point. That's important. So we're going to get some post-lab readings. We're going to go back and check the new pH. Well, there I am. Or at this point I should say, oh, there's some celebrity in the backdrop. Who is that? That guy looks famous, but no. All right, so checking the pH. It's 1, so it's dropped dramatically. A lot more acidic. Correct? A lot more acidic. Doing a little voltage teaching in the backdrop there. Okay, checking the new temperature. It's 22. It's heated up a little bit, so there's been a little energy. You can look. It's hard to see, but that line's raised above the 20 mark a little. It's 22 degrees. So we have our new voltage. We have our ending current, our ending voltage, our ending pH, our ending temperature. So now it's time to check our yield. So here we go. There's our copper on our spoon. And again, remember, the idea wasn't a plating. It wasn't a plating bath. This remediation. We just wanted to capture the copper. All right. That was interesting. Jonathan just grew an extra 2 hands. That's fascinating. So that doesn't happen all the time in lab. So that's why you wear your gloves, Jonathan. Right. Okay, he's rinsing off the product. Make sure you get rid of any waste solution. You also want to, now that you have water present, right, you're going to want to dry that off because you don't want to weigh it now because you're going to have a lot of water weight. And you'll also note that it was a pretty quick rinse. That's going to be important to something you're about to see. Okay, so let's head on over to the, I just saw a monitor with legs on it. Fascinating. Again, that's why we wear gloves in the lab, so weird things don't happen to our body. So now we're going over to the oven to dry it off. So we'll throw that in there or gently place it to remove water. Looks like he's going to dry it for about 10 minutes, so that's good. And so then through the magic of video editing, we can fast forward up here. And here we go. Nice dry, and it's a good hot spoon too. So we got the silicone mitt. Now let's go take the new mass. It's beautiful copper. It's nice. Oh, the legs have walked away from the monitor. Yay. Okay, that's good news. That might have been your classmate Jared in there assisting the monitor. I'm not sure. All right, so in we go on the scale. Get our new mass. This is the post-reaction mass. But caveat, don't necessarily put this in your notebook. You can put it in. I got 39.4640. Real quick calculation on that, and you realize that you're actually at over 100%. So we did a little editing. What we did is we took that spoon back out. We rinsed it more vigorously. That better than 100%. That doesn't make sense. So anyway, what we do, we take the spoon back out. We do a little bit of rinsing, re-drying, and then re-weighing, and we're going to have an adjusted dry mass. So this 39.4470 grams is what you want to enter as your final mass to do your calculations. All right. Well, thank you for your attention. It's really been great working with you. I look forward to seeing you in the lab. Bye for now.